Hello and welcome back to Introductory Electromancy. Today we are continuing to build a transcranial direct current stimulation device, which can be used to run a current through your brain, which will provide a variety of different effects depending on where you place the electrodes. I am particularly fond of this stimulation montage, but this has been discussed more in previous episodes. We have come up with a schematic, we have analyzed the schematic, we have built it on a breadboard, and now we are in the process of transferring it to perfboard so that it will become a permanent device. So far, we've assembled 4 9-volt battery leads, wired them in series, added hot glue to function as a strain relief so they do not break off, and attached the positive terminal of the 4 batteries to the pole of a switch. One of the contacts will go to the rest of our circuit, one will be left open. So now we can basically throw parts on there and make sure that we follow the schematic. Basically. Next up, the power indicator LED, which has a 12 kilo-ohm current limiting resistor. It doesn't matter which way you put the resistor. Isn't that nice? Either way will work. It does matter which way you put the LED. The little flat side is the negative terminal, which is usually connected to the larger metal structure inside of the LED, which may or may not be visible. The LED and the resistor are now on the perf board. In order to make sure they remain flat, press them down on one side, then bend the leads on the other. Bending the leads will hold them in place. One side of the LED goes to the negative terminal. There's an internal connection, and then the other side of the resistor goes to this switch pole, this switch contact, not pole. I have to make sure I use my terms correctly. Now, looking back at the schematic, we're connecting this node here to the resistor, then the LED, then this goes back to ground. But we should note we'll need another wire coming off of this. So we can clip most of these short after soldering them, but this one we actually need for the rest of the circuit. So if we make a 90-degree bend before soldering, it'll make the rest of our lives easier. The goal is to apply solder so that it melts to the wires and to the little annular pad, the copper pad, because that provides mechanical support. And it looks fancier. So these wires, this junction is an internal connection. It doesn't need lead wires beyond. This will provide the positive supply for the rest of the circuit. this needs to go to negative. It's already almost there. So I can simply bend it so it's touching and then apply solder. So now we're further into our schematic. We've made the battery connection. We've added a switch. We've added this resistor and LED. Now we can add the next 12 kilo ohm resistor and 3 diodes in series. This next 12 kilo ohm resistor will still need another lead coming off of it. This is where the plus lead is so far. I suppose it would look best if it were lined up with the other resistor. Press down from the top, bend the wires on the bottom. That's how you keep things connected. Or it's how you keep your part level on the board. That's what I should say. Trying to keep you centered, dear viewer. I'm doing this with the camera zoomed in. I don't know if that's going to cost image quality. I really have to figure out a different camera setup. Something that's amenable to this kind of setup would work. But this is what we've got for now. So there's our positive connection. Now, the other lead of this resistor is going to go to these 3 diodes in series. 3 diodes in series, then back to ground, which is also the negative lead of this power indicator LED. So we get our happy little diodes. It's easiest if you bend the leads before inserting into the perf board. Plus to minus. These 3 diodes go in series. Ah, yes, and it's important that the little silver band be pointed at the negative terminal. It's important that the little silver band be pointed away from the 12 kilo ohm resistor. How do I want to put this? The little silver band is equivalent to this horizontal line, the part that isn't built into the arrow in the diode. That makes sense, I hope. Feel free to ask questions in the comments. I will try to answer them. In order to save space, I'm making these a zigzag shape instead of running them end to end as they're drawn in the schematic. until you get to high frequencies, it doesn't really matter what the physical layout of your board is. So this resistor lead will now connect to this diode right there. This end of this diode will go to this one. Right there. The other end of this diode will connect to the cathode of this diode will connect to the anode of the one below it. And I could map out more connections right now, but the board is already starting to look a little bit like hair or spaghetti. So, solder and clip is the order of the day. This is not my most aesthetically appealing work. It's unfortunate that my handwriting is better and my soldering is prettier when I'm not recording it because of the extra effort spent focusing on making sure that the camera is actually recording what I'm doing. But if I don't record what I'm doing, then there's not really much point in making this video at all. I have already put these instructions out in the world as text because I think that everyone deserves the opportunity to alter their own mind the way they see fit, since they own their own minds, and isn't the whole point of being human to improve? Why not keep improving? Okay, so you can see somewhere in this process one of these popped out. It's not flush with the board anymore. To correct that, press down on one side and reflow the solder on the other. This is a good way to burn yourself, I should mention, and you have to be quick about it. But if you are, you can make your components flush with the board, which isn't really necessary for the device to operate, but it looks better. This goes back to circuit ground, which is over here. You want to bend your wire so that it touches where you're trying to solder to, then apply solder. Then once you have the wire bent and attached where you want it, if you solder to the pad where the component lead goes through the board, it'll make sure that the lead doesn't bend out of that position, though it shouldn't. If it does, it means your solder is broken and your device is, by extension, also broken, which is not good. So now we have the 3 diodes wired in, connected the way they are supposed to be. Which means we have wired this and this and these, and then we're getting to the point where we attach an output to it. Next up, we may as well put in the transistor, the TIP31C. Now, to get these transistors, TO220, to sit flush, flat on a circuit board, bend them like this against a hard surface such as a table. Then bend the leads a second time, and you'll end up with the transistor bent in this manner. Note that this prevents you from attaching a heatsink to it. In this application, this transistor has a much, much higher rating than is necessary. So it's fine to run it without a heatsink. But depending on what you're doing, that might not be the case. So exercise caution. Now this base connection needs to connect to the other end of this resistor, which is luckily right next to it. Isn't that convenient? And you can see that the solder has connected the components together in the desired fashion. So now and you can see that it's not quite flush with the board. You could glue it down. It's because I didn't bend it enough before putting it in, and I soldered it without checking. The easiest way to correct that is to hold it down with one hand, then reflow the joint. Again, a good way to burn yourself if you are not careful. My soldering iron has begun to clog up with oxide. So we put it in the tip cleaning wool, glob some solder on it, tap off the excess. Going to call that close enough for this prototype. So this is the transistor. The base of the transistor is now connected. Now, I'm not going to trim the current output of this up. I'm going to simply build it exactly as I laid out the design, and we'll get an output current of 1.9 milliamps for this particular individual device instead of 2. So we use a 100 ohm resistor and then a 560 ohm resistor in series. And those go back to ground. And those go to the emitter, so that's here. All right, and then global ground of the device is up here. So I guess I'm going to put these resistors here physically. And this goes to ground, 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 ground. This is the emitter pin. All right, so the emitter of the transistor goes to the 100 ohm resistor, then the 560 ohm resistor, and then finally to ground. That is this portion of the schematic. So then we just need these two 2.2 kilo ohm resistors and some output leads. Apologies for being so quiet. It's easy to get wrapped up in these things. Meditative. Really is a peaceful activity. And I have to focus on it so I don't make any mistakes. So this will be the positive output lead. As you can see, it comes from plus at the batteries through the switch and then is connected directly to this 2.2 kilo ohm resistor, which is the same as the schematic plus at the batteries through the switch through this 2.2 kilo ohm resistor. Then the other 2.2 kilo ohm resistor gets connected to the collector of this tip 31C. Which is the center pin. And that'll be the negative output lead. Tricky. So these are all connected. Now we just need output leads. These are 2mm pin electrodes which interface with gel electrodes such as these, and they are pretty easy to get. They're sold as TENS electrode leads, TENS, that's for transcutaneous electronic nerve stimulation, which is their more commonly recognized use. Now, I think I'm going to split this last part into one more video because there are a few things that I want to talk about and I'm not sure if they'll fit in the roughly half-hour time limit that I'm following for these things. So hang on a moment, dear viewer.